Hello friends, grab your coffee, grab your cookie, but today, keep both far away from any powder metal production line, because we are talking about four of the most dangerous metal dusts in modern industry: tungsten dust, molybdenum dust, lithium dust, and cadmium dust. Each one behaves differently, each one comes from a different industry, and each one requires completely different engineering controls. I am Michael Klepik, and for 15 years I've been designing dust collection and air purification systems for metallurgy, battery manufacturing, hard metal processing, aerospace, and chemical production. Let's take a deep breath, metaphorically, not literally, and dive into these four difficult materials. Technical description of these four dusts. These dusts vary dramatically. First, tungsten dust ranges from 1 micron to 10 microns, with a massive bulk density from 8,000 to 12,000 kilograms per cubic meter. It consists of tungsten metal or tungsten carbide, extremely hard and extremely abrasive. Second, molybdenum dust ranges from 0.5 microns to 20 microns, with density from 3,000 to 5,000 kilograms per cubic meter. It includes metallic molybdenum and molybdenum oxides, and is chemically stable but respirable. Third, lithium dust is extremely fine, from 0.1 micron to 5 microns, with low bulk density from 200 to 400 kilograms per cubic meter. It is highly reactive, hygroscopic, and can ignite spontaneously in moist air. Fourth, cadmium dust ranges from 0.2 microns to 15 microns with density from 4,000 to 5,000 kilograms per cubic meter. It includes metallic cadmium and cadmium oxide, both extremely toxic and carcinogenic. This group includes heavy dusts, reactive dusts, toxic dusts, and pyrophoric dusts, all in one dangerous family. Where these dusts are generated, each dust originates from very different industrial processes. Tungsten dust appears during hard metal grinding, tungsten carbide tool production, thermal spraying, and additive manufacturing powder handling. Molybdenum dust appears in alloy production, catalyst preparation, thermal spraying, mining, and metallurgical refining. Lithium dust is generated in battery manufacturing, cathode and anode powder handling, lithium salt blending, crushing of lithium metal, and recycling of lithium ion cells. Cadmium dust is generated in battery plants, electroplating, pigment production, alloy machining, and smelting operations. These are completely different industries, but the dust hazard is equally serious. Why these dusts are dangerous to human health? The toxicology varies significantly. Tungsten dust can cause lung fibrosis when inhaled in carbide form. Molybdenum dust irritates lungs and can cause pneumoconiosis. Lithium dust reacts with moisture in lungs, forming corrosive compounds. Cadmium dust is one of the most toxic industrial dusts, a carcinogen that causes kidney failure, bone damage, and severe respiratory injury. Cadmium and lithium are the most dangerous biologically, while tungsten and molybdenum are the most dangerous mechanically. Combustibility and chemical reactivity. These four metals represent all ends of the reactivity spectrum. Tungsten dust is non-combustible but extremely abrasive. Molybdenum dust is generally non-combustible but can oxidize at high temperatures. Lithium dust is violently reactive. It ignites spontaneously, generates heat with moisture, and forms flammable hydrogen gas. Cadmium dust is partially combustible in oxide form and releases toxic fumes when heated. Lithium is the most reactive of the four and requires Class D safety measures. Behavior and airflow. From an engineering perspective, tungsten dust is extremely dense and settles quickly unless duct velocities are very high. Molybdenum dust is moderately dense, stays airborne during grinding, and embeds into filters. Lithium dust is extremely lightweight, travels easily, absorbs moisture, and can ignite inside ducts. Cadmium dust behaves like toxic smoke, coats surfaces, and deeply penetrates filters. You cannot design airflow for these metals using the same assumptions. Each behaves like a different species of material. Best filtration equipment for each dust torch air offers different solutions depending on the hazard. Tungsten dust, the Blizzard Baghouse with abrasion-resistant steel and ceramic-lined inlets. Molybdenum dust, the FOEHN Ultra Cartridge Collector with membrane-coated filters for sub-micron capture. Lithium dust, the Tornado Scrubber or Cyclone Torch, both spark-free and compatible with inert environments. Cadmium dust, the FOEHN HEPA Plus Toxic Metals Collector with sealed HEPA final filtration. These materials cannot share the same dust collector type. Each demands a unique machine. OSHA, NFPA, and hazard compliance, tungsten dust. OSHA nuisance dust limits and carbide handling rules. Molybdenum dust, OSHA exposure limits for molybdenum oxides. Lithium dust, NFPA 484 combustible metals with restrictions on water, sparks, and air moisture. Cadmium dust, OSHA Cadmium Standard 29 CFR 1910.1027, one of the strictest toxic metal regulations across all four metals. First, medical surveillance is often required. Second, filter change-out protocols must be sealed. Third, explosion isolation is required for reactive metals like lithium. Fourth, housekeeping must be strict. Fifth, HEPA polishing stages may be required. Dust collector system design. A complete system for these four metals must be engineered differently for each hazard. I design, first, differential pressure sensors to monitor filter loading and detect leaks, especially important for cadmium and molybdenum. Second, oxygen-reduced or inert atmospheres for lithium dust to prevent ignition. Third, abrasion-resistant steel and ceramic liners for tungsten and molybdenum. Fourth, automatic dust discharge systems into sealed steel drums for cadmium and tungsten. Fifth, spark-free mechanical separation for lithium to avoid filter ignition. Sixth, conductive and grounded ductwork to reduce static with reactive metals. Seventh, multi-stage HEPA or OLPA filtration for toxic, respirable cadmium and lithium particles. This is a true multi-metal, multi-hazard dust collector, not a general-purpose system. Tungsten, molybdenum, lithium, and cadmium dusts are completely different materials with completely different hazards. Some are toxic, some are reactive, some are abrasive, and some are explosively dangerous. But with proper engineering, correct filtration equipment, and strict OSHA and NFPA compliance, these dusts can be controlled safely and reliably. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, metal belongs in your product, not floating in your breathing zone. See you in the next video.